Module 2 Investigation 7, which is the last investigation for Module 2. We're going to talk about the absolute value. So, we need to see what's the absolute value. So, absolute value given as a number in C is greater than 0. So, the meaning of the absolute value x minus h equal to c represent all the values, which is right here. All the value of the x exactly the c units away from the from the h. Okay, so if you have a h here, right, and then every you go to the right from this h or left to the h, right, and then there's a c units away. So this is a c here. So it's not c. I mean c units away. So yeah, this is what it is. Okay, so the absolute value is all about the distance, and then when they say less than c, which means it has to be the from here to here. Oh, sorry, it's gotta be from, yeah. So this is a amount of the c. Of course, this is actually the c, and then greater than c means you're looking for this more than c cases as a values. Okay, so what we gonna do is a 6. So Jamie's assembling a model airplane that flies. The instruction says that the best final weight is 28.5 ounces. However, the actual weight can vary from this by up to 0.6 ounces without affecting how well the model flies. Representing the weights are the acceptable on the number line, and then describe them using inequality here. Okay, so at on the place, I think I want to put down the 28.5. So let's say individually about the number in here. So if I say this is 28, 29, 30, 31, 32. I think it's a 2. Sharp this one, sorry about that. So if I put this at 28 and then 8.5 and 28.6, 28.7, 28.8, 28.9, 29, right? And then 29.1. If we go to the left, and then you got 28.4, 28.3, 28.2, 28.1, 28, and then 27.9 and 27.8. Okay, so the final instruction means it's the best to have a 28.5, but you have actually the flexible ounces to get a little more than 6.6 ounces to as a more or less. So if you go to 0.1, 2, 3, 4, 5, and 6, so it's up to here, and then you got 1, 2, 3.4, 5, and 6 in here. So that's this whole thing is 0.6 ounces more, and up to here is 0.6 ounces less, up to the 27.9. So I want to say weight could be from the 27.9 and then up to 29.1. And then B, write the mathematical statement inequality that represent the acceptable version and for a variation in the model's weight. So using the absolute value, which means whatever the weight you have to the 28.5 should be less than equal to 0.6. Okay, so difference between the weight of the airplane from the whatever airplane you have as a weight, and then should not be greater than or equal to 0.6, should be the less than or equal to 0.6. And then without the using absolute value, you can write as x minus 28.5, which is x is a w though. It's going to be 0.6, and the left side is going to be negative 0.6. So you can write this one without the absolute value, okay? So these two are the equivalent. And also, I want to talk about 9. So use the absolute value notation to represent the following. So all the number x whose distance from the 6 is no more than a 7.5, okay? So which means all the number x distance from the 6, so distance with the absolute value, okay? No more than means less than equal to 7.5. But all the number r distance from the -2, right, is going to be more than, which is greater than 1. Yeah, so which is, if you rewrite this, 2 negative become positive. So this is what it is. This for this answer, and this is the answer for B. All right, that's for it. Okay, thank you for listening.